Action.
We're at the East Branch of the Fond du Lac River. It's also located, or known as Morris Court, in the SWIMS database. And we've completed our water monitoring here, which includes measuring the temperature in the air, the water, the pH level of the water, then the flow of the water, the depth of the water, and the clarity. And all of that information then gets entered into the SWIMS database, which is accessible to DNR researchers and others, anybody else in the state of Wisconsin. And it's a constant record that we provide for this river. Being the East Branch of the Fond du Lac, it is also monitored in Parsons Creek and Campground Creek, which is above this area. So we have a nice history and a picture each year of what's happening in the East Branch of the Fond du Lac River.
Prior to going out to do the river testing, we need to calibrate our instruments, and here we're calibrating the pH meter, and you can see the electrode there is in an envelope of pH buffer, and that's the 7.0. Okay, so basically you can just open up that envelope and stick the pH probe in there, and then you allow the pH meter to stabilize, and once it detects what pH is in the sample envelope, you hit an enter button, and that will calibrate the pH meter to 7, and we're also going to do it to pH 10. This is the dissolved oxygen meter, and we also have to calibrate this one before going out to do the river testing. And you can see the probe, and how we calibrate this is the probe be inserted in the slot underneath the dissolved oxygen meter, and there's a sponge in there that has distilled water in it. And so that's going to be equilibrated with the air, and you need to record the temperature, and since we know it's distilled, then it will have a certain reading of milligrams per liter of dissolved oxygen. And here we have a little chart that we just would look up based on the temperature and what it should be at saturation.
Waiting for this to stabilize, which usually takes a minute or a minute and a half or two.
Here we are on the Fond du Lac River. Is this the East Branch of it?
Yes.
Okay, East Branch of the Fond du Lac River, just north of the Pioneer Street Bridge, and Diana Beck's in the water there, measuring dissolved oxygen content. So basically it's a little probe that she has in the water and reading the dissolved oxygen off the meter, and just kind of waiting for it to stabilize.
Okay, looks like water temperature is 16.7.
The water temperature is 16.7.
Okay, and milligrams per liter is 9.0.
And the dissolved oxygen is 9.0 milligrams per liter.
And then the percent is 92.4.
And that's 92.4% totally saturated. So that's pretty good oxygen content. We've had some storms recently, so pretty fresh water.
This hour of the day. Drought.
Here's the pH measurement, and basically we just collected that jar of river water, and we have the pH probe, and there's a temperature probe because pH is temperature dependent, and just letting the probe sit in the water. And let's see here the monitor. The next step is to fill the turbidity tube, and this is a very effective device, very simple, but it's basically a very long tube, and you just get some of the river water into it, flush it a couple times.
Just to rinse it.
Okay. And then how we read this is basically look down the tube, and there's a little white and black disc in the bottom of it, and you keep lowering the level till you can just see that white and black disc, and that will give you a turbidity reading. Okay. Here we're letting water out of the turbidity tube, and you can just see right at the bottom there's the white and black marking.
That's a Secchi disc.
And then as we're doing that, Dan is looking down the tube, and just trying to watching when you first see that Secchi disc.
The water's not very clear.
Can you stop for a minute? Or
Yeah, why don't you just
see if you can?
just to re-
This part of the protocol, we're measuring the river depth, and we want 20 increments across the river.
I'd say 0.78. Just a little higher.
4.89.
So since the river is about 30 feet at this point, we're going at 1.5 foot increments. So you can see we have a
1.0.
tape going across the top of the river there, and Diana's just putting in a pole that's marked with foot and tenths of feet markings. I'm just reading off the depth of each of those 1.5 foot intervals.
8.15.
Types of stuff.
Here we're measuring the river flow rate by throwing a tennis ball into the river, and then we just time it over how long it takes to go downstream 20 feet. We can do this in 4 different spots along the river and have somebody down at the end to catch the tennis ball so we don't lose it.